Good morning, grade 7. I hope, inshallah, that you will enjoy with the first chemistry session about the revision of earthquakes. Now, inshallah, we are going to study and make a revision for the first lessons that we studied at Module 3, which is called earthquake. First, we are going to make this revision to remember data about the earthquake, then answer some question about this lesson. Number one, earthquakes. where where do earthquakes occur? What are seismic waves? Why do earthquakes happen? Okay, so after that, where do earthquakes occur? Earthquakes occur all the time, all over the world, both along plate edges and along faults. Most earthquakes occur along the edge of the oceanic and continental plates. Earthquakes usually occur where two plates are running into each other. Why do earthquakes happen? This is types of fault that is the main cause of earthquake. Normal slide fault at left, normal slide fault, mountains and valleys. Okay, about after the occurrence of normal slip fault, mountains and valley will be reduced. There is another reverse fault. Okay, one reverse other one, and trust fault, another one, and strike slap. All of these are types of fault that occurred, then earthquake after that occurred. This is normal fault. The crack is formed when one block of rock slide downward and away from the other one, as this has a shape of normal slip fault to form mountains and valleys. After that reverse fault, the crack is formed when one plate is pushing another plate, okay, causing one block to slide under tension. Okay, have this reverse fault and another reverse fault. After that, a strike slip fault, the crack is formed between two plates sliding past each other. Example as sun and fast fault. This is sun and fast fault. This fault. Okay, that's strike, slap. So trust type of reverse fault that has very low angle of this. Okay. Pacific plate is the largest tectonic plate on Earth. Pacific plate. Seismic waves release energy which you have built up inside the rocks. Fault are cracks in Earth's crust. Fault are cracks in Earth's crust. Three main forces: tectonic tension means pulling, compression means pushing, okay, sharing force in all direction. Okay, so all this data about the earthquake that we are going to review in some question. Okay, after that, the question that you are going to study. Question number 1. The surface along which the crust moves is called a fracture. The surface along which the crust moves is called fracture. True or false? Yes, it's false. Not fracture. Surface along which crust moves is called not fracture, called fault. After that, number 2 is responsible for most of the damage building suffered during earthquake. What is the main responsible for the most of damage building suffered during earthquakes? Yes, liquefaction. Liquefaction. Okay. Liquefaction. Sorry. I'm sorry. Liquefaction. Number 3. The forces that move tectonic plates also move rocks along the fault. The forces that move tectonic plates also move rocks along the fault. It's true because this force that move tectonic plates also move rocks along the fault. It's true. Number 4, the larger the force applied to a fault, the smaller the chance of a large earthquake. Larger force applied on the fault, the smaller the change of the large earthquake. False. Larger force, so larger the chance of a large earthquake. Okay? Larger the force applied to a fault, so the larger the chance of a large earthquake. Question number 5. For the Richter scale, each increase on the scale represents 10 times the amount of ground motion recorded on the seismogram. How much more motion is there for a magnitude 7 earthquake than a magnitude 4 earthquake? 3 times, 30 times, 1,000 times, or 3,000 times. Okay, how much more motion is there for a magnitude 7 earthquake than magnitude 4 earthquake? It will be 1,000 times. It will be 1,000 times. Question number 6. Which scale would be used to classify an earthquake based on description found in ancient writing? Modified Mercalli scale, Richter scale, moment magnitude scale, all of the above. Okay, in ancient writing, which scale would be used to classify an earthquake based on a description found in ancient writing? So it will be a modified Mercalli scale. A modified Mercalli scale. It's okay. Question number 7. Looking at the figure that shows worldwide earthquake distribution, the white lines represent plate boundaries. Which statement is true? Okay, looking at the figure that shows worldwide earthquake distribution, The white lines represent plate boundaries. Which statement is true? Deep, a deep earthquake are more common than shallow earthquakes. Shallow earthquakes are more common than deep earthquakes. Shadow earthquakes and deep earthquakes are equally common. Shallow earthquakes do not occur along plate boundaries, but deep earthquakes do. What is the best answer for this drawing? It will be what? The answer will be B. Shallow earthquakes are more common than deep earthquakes. Shallow, white lines will be more common than deep earthquake. Sure, because shallow earthquakes represents white lines, while deep earthquake represented by dark lines. So shallow earthquakes are more common than deep earthquake. Question number 8. When the force on rocks is great enough, they break, producing vibration, called what? When the force on rocks is great enough, they break, producing vibration, called what? Fault, earthquakes, strains, stresses. It will be earthquake. It will be what? It will be earthquakes. Okay? When the force on rocks is great enough, they break, producing vibration called earthquake. Question number 9. Describe and compare the three types of scales used by scientists to measure and describe earthquakes. Describe and compare the three types of scales used by scientists to measure and describe the earthquakes. What about the three types of scale used by scientists? What about them? This explanation that can be answered. Okay. What is the explanation? Can be answered. The Richter scale measures the energy or magnitude of the largest seismic waves produced by earthquake. For each increase of 1 unit on the scale, an earthquake releases 32 times more seismic energy. The moment magnitude scale measured the total energy released by the earthquake, taking into account the size of the fault, the motion along the fault, and the strength of the rocks that break during the earthquakes. The modified Mercalli scale measures the intensity of an earthquake based on the description of the effects of the earthquake on people and structure. Okay, so this explanation about the three types of devices which are used by scientists to measure the earthquakes. Question number 10. The map shows fault located near the Pacific and North American tectonic plates. including the San Andres Fault. Arrow indicate direction of motion on either side of the fault. This is two tectonic plates along the west coast of the United States. This United States relative motion of North American plate, San Andreas Fault, this San Andreas Fault, and this is another relative motion of Pacific plate. So it's the relative motion of North American plate, and this is vice motion, reversed motion of Pacific plate. Okay, and this is Mexico. Number 8, identify a natural hazard commonly associated with the geologic features shown on the map. Describe the relationship between these features and the hazard. Okay, this is the explanation. Number B, describe two technology used to monitor this hazard. Describe two types of technology used to monitor this hazard. Number A, earthquakes. According to the earthquake, the result are created when stress, which builds as the plates slide past each other, is suddenly released during an earthquake. Number B, types of technology include number 1, seismometers. Seismometers are fixed to the solid ground and record checking of Earth's surface. GPS system. GPS systems also creep meters, stream meters, charlotte meters are used to monitor the slow movement of Earth's crust. And note, it's acceptable for students to describe the technology and how it's used without knowing the specific name. Okay, this is related to the students. So GPS systems, also creep meters, stray meters, charlotte meters. Okay, according to the GPS system. After that, question number 10. Tsunami are huge waves. Tsunami are huge waves generated by sudden movement of the ocean. Tsunami are huge waves generated by sudden movement of the ocean floor as a result of an earthquake. To help predict tsunami, scientists monitor earthquakes along the ocean floor. The map shows the risk level of tsunami around the world. And this is Pacific Ocean, this is Atlantic Ocean, Indian Ocean, and Pacific Ocean from the other side. Okay, this is black, high risk of tsunami. This is gray, moderate risk of tsunami. Okay, light gray, low risk of tsunami, and black line, high earthquake occurrence. So based on the map, which solution would be the most effective use of technology for monitoring tsunami threats? Number 1, lookout towers located along the coastlines with camera that search for waves moving toward the beach. Sets of piles located at various distance and depth from the shoreline that measure changes in water level after an earthquake. Satellites in space that monitor changes in ocean water temperature, or computer generated maps that show earthquake strength and location and the speed and wave height of past tsunami. The best answer will be number B. Sets of bios located at various distance and depth from the shoreline that measure these changes in the water level after an earthquake. Okay. After that, the I think that we finished this revision about the earthquake. Okay. I hope that grade 7 enjoyed from this revision chemistry session about the earthquake. Happy Ramadan for guys, and we are going to meet inshallah each other in the next session of revision about the next lesson, which will be volcanoes. Okay, happy Ramadan, guys, and goodbye.